All right. Well, this week, Windows DNS. We've talked about DNS over and over and over and over again. More just kind of referring to it. You played with it a little bit in network directory services, so you should have a pretty decent idea of what it does. I don't know how deeply you guys went into configuring it, but we're gonna do it. This is the time and the place to get it all figured out and what it does and why it exists and all of that kind of fun stuff. So, what you're gonna need, obviously, your pfSense machine, your Windows server, and a Windows client. Any client will really work as long as it's on this network, but the Windows client is what I've got in the lab. So, that's what you're looking for. So installing roles is pretty simple, so I won't go too far into detail on that, but obviously your server dashboard, manage, add roles. This is something that you should have done a few different times in your NDS class. Find the correct role. So the DNS server role here, it's going to ask you to install some additional tools. You do want this. If you skip this, you won't be able to manage DNS except for remotely. And those are just some hoops that we don't necessarily want to jump through right at this moment. So do add those features. And then we'll go through. So a lot of this, and especially for those of you that do end up having questions and things.
I've got a question.
Sure.
I was going to say, are you sharing your screen? Because
Oh,
nothing.
yeah, I'm sharing my screen with OBS, but not with. There you go. So just to recap, I didn't do anything special except for manage, add roles, next, role based. Make sure you got the server selected, DNS, add features. The rest of it's in the video, slower than that. But anyway, from there, hit next. And it's going to give you some basic information about it. I mean, this is literally going to explain to you what DNS is and how it affects DHCP. It's something that we're going to have to deal with as well. So the cool thing about this is that we can turn it off on pfSense once we're done here and allow Windows to take full control of DNS. But there's a little bit of configuration that we want to do before we make that change. Otherwise, we'll start running into some issues. And I'll also go over a few things that you need to watch out for to hopefully get you guys a little bit better understanding of what DNS does and how important it is. So something that we're going to look forward to, DNS server integration with Active Directory. This is something that we have to be careful with. When we get to the Active Directory lab, we're going to remove DNS and let Active Directory reinstall it for us. Otherwise, we have to make a laundry list, speaking of laundry list, of DNS records to actually get it to all work. So instead of doing all that, we're going to let Active Directory install it and then go review what kinds of records that it created. So anyway, just some information looking forward about Active Directory. So this is what DNS is and how it affects DHCP. This is how it affects Active Directory, how Active Directory affects it. And that's it. I don't think it's going to require a restart, so you don't have to check that box. But go through the install and let it do its thing. So here, at this point, while you're waiting on this, it shouldn't take too long, but while you're waiting on this, take stock of all of the host names that you have on the Windows side of your network. So you can figure out your own host name, your server host name right there, SVR-01 on your Windows VM. Well, on any Windows VM, any Windows machine, you can just go to the command prompt, type in host name, and that's it. We don't want these. Those are absolutely impossible to remember. The whole point of DNS is that you're using names that you can remember. And I don't know about you, but Sally over in accounting is not going to remember desktop-0QRIMCH. That's just as hard to remember as an IP address. So do not keep names like that. Go in and actually change them. So in this case, we can go to System, rename this PC, and then name it something else. I named my VM 10, so I'll just name the actual host name of this machine 10. Now this, yep, got to restart. Does not take effect until you restart. So this is actually not necessarily mandatory. DNS is going to override whatever you've got there as far as people trying to contact you. So it's not strictly mandatory, but to have everything agree, you want everything to have the same name. So I'll show you what I'm talking about with that record there. But that's it. So while I changed that host name, this finished up. We closed this up. And that's pretty much it. You look at DNS over here. It's running. There might be a couple of warnings for you to look at. Probably not. Let's see. Oh, so it's complaining about not having a fully qualified domain name. So we'll fix that just as a matter of course. Once we do Active Directory, that will take care of it. So basically what this is saying is, hey, we don't have a full-on domain name, but I'm still going to do naming for you. So we will come to that. All right. So right there. So we need to create a forward lookup primary zone, and we're going to do the reverse as well, but let's focus on the forward. So here's the deal with forward and reverse. So forward lookups. This is exactly what you do every single day that you're on the internet and you type in any web address and then you end up on a web page. You have done a forward lookup whether you know it or not. So you type in a website you haven't been to in a few days. Let's say that's cnet.com, right? You haven't been there in a week. Your DNS cache is probably has been flushed by now, which means that it's not remembering it because you haven't gone in a long time, so there's no use in remembering it. It will just go look it up again if it has to. So what you're doing is you're typing in cnet.com, and it comes back with an IP address, your browser. You type that into your browser, the system does a name lookup, DNS lookup, and then an IP address pops out. So let me show you what I mean by that. I think DNS lookup is here. Right? Yeah. So you do cnet.com and it runs out and says, hey, that IP address is that. So it turns out when you type in cnet.com, your browser doesn't actually look up cnet.com or use cnet.com to get to places. It actually uses the IP address. And so this whole process of you give it a name and then it returns you a number happens every single time you go to any website that's listed by name. And that's like all of them. How many IP addresses do you go to on a daily basis, right? Probably zero, manually anyway. So this lookup happens every time you try to go somewhere. That is a forward lookup. And each, your DNS locally on your machine will remember these. This is a DNS cache. It will remember these for a short time. And so will your DNS server. So it does this caching so that it can save a few milliseconds by not asking the actual DNS server. So think your ISP's DNS server, your Google DNS server if you've changed them. Cloudflare has one. OpenDNS has one. There's a bunch of different options that we'll go over here in a little bit. But the idea is that on the internet there are DNS servers that will answer any question. Not every DNS server knows the answer to every question. There are authoritative DNS servers for specific domains. So, long story short, DNS is distributed. No one server out there knows every answer to every question. Doesn't exist. You ask a server, and then they play the telephone game, except computers are way better at playing this game than we are as humans. They don't actually lose any information in translation. So whether you're asking 4 different servers for an answer or 1 different server for an answer, it doesn't matter. The IP address is the same. No matter, if you ask for CNET, no matter where you are in the world, you're going to get the correct IP address. I can't say the same IP address because there are a lot of new services out there that do things like hyperscaling where you could get a totally different IP address depending on your region. So yeah, you will get the right IP address. We can put it that way. So if you want to think about it this way, if you've been around for a little while and you remember what a phone book is, that's what this is. DNS is just a phone book. You want to get to Joe's Pizza and you want to know how to contact them. So you do a lookup. If you're younger, you do that on Google. If you're older, you do that in a phone book. But long story short, you swap Joe's Pizza for their phone number. So to connect up to Joe's Pizza, you can't just open up your phone and type in Joe's Pizza. Well, actually, I take that back. Some of the smartphones can do that. But generally, you type in the phone number. That's how DNS works. That is a forward lookup in DNS. I have a name. I want the number. The process of getting that number is a forward lookup. Reverse lookup is exactly the opposite. You've got the number. I know the IP address, and I want to find out the name. A reverse lookup is the only way that you're able to do that. And here's the kicker about reverse lookup. Not every DNS server is configured for reverse lookups. We're going to go through that process just so you see how it works. But typically, you don't set this up on local networks either. This is more of an internet thing. But we're going to go through that process. Anyhow, so enough of the network directory services lesson. Let's go to the practical side of this. So there are a couple ways to get to the DNS snap-in. Same as DHCP, you can go to Tools, DNS. But if you select DNS over here already, you can right-click here on your server, go to DNS Manager, and it'll take you to the same spot. So this is the same thing as going Tools, DNS. So if you look, you've got forward lookup zones and reverse lookup zones already. This is just Windows being fairly nice to you. And here's what you want to do. So in your forward lookup zone, you want to create a new one and name it win dot your first initial last name .io. Don't put that comma in there. So for example, me, I would be win.elchavez.io. All right. So first initial last name .io, but put win in front of it. So here's the deal. We're declaring a few things right now. Our top level is IO. So what we're saying is there's a server out there that that has the basic answer for all of the IO domains. So it will know about El Chavez. And it will learn about El Chavez by the DNS registrar that I go with. So let's say I go to Ionos or I go to GoDaddy or something like that, and I register elchavez.io. Those servers inform the authoritative servers for IO about that. Anyway, and then once you've got that figured out, you create a subdomain. That's what this is. So elchavez.io, that is mine. After this, I can make whatever I want. I can have as many subdomains as I want. I can put Win out here, Lin out here, Leo out here, anything that you want to that is that you're able to actually use via DNS. So pretty much letters, numbers, and dashes. You can get away with just about anything doing that. So it's basically mine. Once I own elchavez.io, anything to the left of that is mine. So think about it like this. Each level here between the periods is more and more specific. So if you move to the left, dot something, dot something, dot something, you are getting more specific. If you are moving to the right, you are getting more generic. So IO, I'm not the only one that's using IO. Tons of people can use IO. As long as they spend their $20, they can have something.io. For me, that's this. So this is what I go out and buy. Then I can create subdomains out here to specify different websites that I'm running. So win.elchavez.io is in this case, my internal domain. This is how I will identify the network that I'm running at work or at home or wherever. And then I can just make more and more and more and more. So as we get into Active Directory, you're going to realize, or actually, as you get into this lab, you'll realize that adding to the left gets you more specific, because what we're going to have, I named my Windows 10 machine 10. So once we get into the DNS, we're going to have 10.win.lchavez.io. And that's going to be a very specific resource on the win subdomain of the lchavez.io domain. Anyway, it'll make more sense when you see it, but that's the general idea. Okay. So we want to add this zone, right? Forward lookup zones, right-click on it, new zone, and then it's going to walk you through how to do this. Do not just next through this. Pay attention. Read what's going on. This lab is actually a primer to the Linux lab. If you don't know what you're doing here, you won't know what you're doing in Linux, and it's going to be way harder to do because you literally have to key in everything. There is no wizard like this in Linux. So pay special attention and read the options that you're choosing. Otherwise, next lab is going to be really hard, unnecessarily hard. Okay, so primary zone, that's what we want. This is basically just going to be the zone that we set up on this server, and this server is going to be authoritative on that zone. We can create more DNS servers later on and attach them and do all that kind of fun stuff, but for right now, just one. So primary zone. And what are we calling it? So in my case, win.lchavez.io. Right? So you want the whole subdomain to exist here. And then this is going to get created. So this is going to be the zone file where all of the information that we create as far as records go ends up. If you already have one, you can use this. In Linux, you get to write this manually. Everything that goes into that file, you get to write it manually. But in Windows, you get to create records and they just get linked. So the text files have much less affinity for making typos and things like that. So, in this situation, you are kind of you're in a scenario where if you only have one DNS server, you don't want any of this stuff. But if you're running multiple servers, you want to decide how exactly one server is going to communicate to another. So think about it like this. If you have two DNS servers and they both should be able to answer all the same questions, you don't want to have to go to one, create the record, and then go to the other, create the record. That is much more opportunity to typo and make mistakes and things like that, right? So what you want is you want servers to update each other. You put it on one, a few seconds later, it shows up on the other, right? So making a DNS change should only take about a minute from the time that you create the record to the time that it updates to the time that it is available for everybody to use, no matter which server they're using. So in this case, in this scenario, we only have one DNS server, so we don't want to be updating anybody else. This is a security issue. Think about it. If you have 100 different machines, all named, all have IP addresses, and you tend to name your machines like cattle, as we haven't talked about that before, but cattle rather than pets, right? So instead of naming your server Superman, you name it Server 1 or Active Directory 1 or DNS 1, something like that, right? It's very informative. So this is what is considered a zone transfer. This will allow, if you allow zone transfers to anybody, this will allow anybody on the internet or anybody with access to this DNS server to say, hey, what you got? And the DNS server will just give up everything. It will say, oh, here, look, I have this list of all of these different things that they're at these IP addresses, and here are their names. So that is not necessarily something that you want to, information that you want to give to just, random person. So we do not want to allow these updates in a single DNS situation. Now this, not so much. This is going to allow non-secure and secure, which basically means Windows will just allow you to ask the question and it'll answer the question for you. The only way to get anything more secure is to use Active Directory. Windows ties a lot to Active Directory. So leave this at do not allow. It does make a difference, so be aware. And that's it. Finish that up, and you're good. Once you go inside of here, you can start creating records. Now, this is actually going to correct you a lot if you're going to be doing weird things like trying to put PTR records or something like that in here. It'll prevent you from doing that, and if you end up moving a PTR record here, it'll end up redirecting it to the right spot. So it's actually fairly difficult to make mistakes here. But what I want you to pay attention to is forward lookup zones. Once you get into it, what does it allow you to create? Not PTR. There are clues here to help you out in Linux where, think about it like this, I guess. Windows, you know when you go bowling and you can put those little inflatable kitty bumpers on the side and the gutter so you actually don't make a mistake and you actually hit a pin every single time? Yeah, that's what Windows is doing for you right now. You got the little kitty bumpers on. When you get to Linux, no kitty bumpers. So pay as much attention as you can. Practice as much as you can on the Windows side to understand all these words, terminologies, things like that. Anyway, so we want to, let me see. I don't create anything just yet, so we'll follow along. Anyway, reverse lookup zone. So let's go and create that. So basically the same exact thing. New zone in the reverse. You want it primary, of course. It's going to be for IPv4. We're only using IPv4 here. And then you want the network ID. It does not want a network IP address or anything like that. It wants the network ID. So in the case of my Windows network, which is 100, 172.16.100, you're done. Take a look at what it creates. Again, something to note for Linux. This is what a reverse lookup zone name actually looks like. And you generate this from your network ID. Notice it is backwards. So basically what this is saying is when you create this zone, it says, okay, well, I will prepare to have the answers for when people ask for 172.16.100.anything. That's what belongs in this zone. And we'll start creating some of that. And then here it is. It's going to try and create that file name for you. Again, with the updates, leave it, and then finish. And then you will have both of these zones. Feel free to create more and test around with. That's not a problem at all, and it'll actually work. This DNS server will answer those questions. So I do encourage you to branch out a little bit. Create a separate forward lookup zone. That way you don't blow up your own stuff. And you can test. Do test.lchavez.io or test.whatever your domain is.io. And you'll run into, you probably won't run into issues, but as long as you do the lookup, NS lookup on the stuff that you've created, then it should work. All right. So before we start creating records, we also want to configure DNS forwarders. So pfSense, whether you knew it or not, is already forwarding your stuff on. It's already created all this for you. So right here, you actually have to do it yourself. So I don't remember when we set that up exactly what we used pfSense, what pfSense is using as a forwarder, but we'll look at that right now. So properties of your server. So right-click on your server name, properties, forwarders tab. This is important. There's a thing called conditional forwarders down here that is not what you want. Do not configure anything in conditional forwarders. It is not part of the lab. So yeah, for the I will find out which one of you guys watches the video by that one thing right there. So anyhow, what you want in this scenario is forwarders, edit, and then it's going to ask, which ones do you want? You can use whatever you'd like. right there. And 8844. There we go. Cool. 8888 validated, 8844 validated, cool. If it comes back as unvalidated, either one of two things has happened. Number one, you cannot route out to the internet. So that's a pfSense issue, or you've misconfigured your IP addresses. And the other, well, no, I think that's pretty much it. Yeah, you misconfigured pfSense somehow, or your IP address. Those are the two scenarios in which this will not work. So you need a checkbox on this before you move on. If you do not get checkboxes or it says validated, okay, your lab will not work. You will not have internet after this point. So make sure this is working. If it's not working, either fix it or let me know and we can fix it. One of the two. So you need forwarders in here. So what happens here is your Windows server is not going to have an index of every single name on the internet. That's just not how that works. Google, however, does. In general, it's a cache. So it remembers the most used names on the internet, and for those names that it doesn't know, it will figure it out. It will go to the authoritative server, DNS server for a particular domain name and ask, hey, what's the IP address for this guy? And then it will cache it. And then it will tell you as well the answer to that question. So long story short, Google will handle it. If you don't like Google, you can use other things. So get rid of those. We can use 1111. Was it 1001? I think that's what it is. Yeah, sure enough. You can use those. This is Cloudflare. OpenDNS, I think, is 9999. You do not have to use them all. Pick a service, stick with it. If you want security, sure, stick 8888 down there. But you don't want 12 different DNS resolvers down here. You just want a few, 2 or so. All right, well, that's it. Bingo, bango. You should be able to get on the internet using the Windows Server DNS at this point. For any answer that Windows DNS does not know, it will forward on to the IP addresses that we just listed. That is the whole point of what we just did. And your Windows Server DNS is not going to know a lot. It's just going to know local stuff. And from here, shoot it onto the internet. All right, so change DNS server scope option. Oh, in DHCP. Okay, so we've got to go into DHCP now. Now that we've got DNS basically configured with forwarders, we now have to go into DHCP to inform everybody else of that. So, get into your DHCP manager or tools DHCP. That'll work as well. I'm going to close this so I don't get confused. I'll come back to it in a minute. Come back in. You want to find your scope options, because your scope options DNS server is now wrong. We want to use Windows Server's DNS instead of pfSense's DNS. So all we got to do, find a scope option, remove that one, add that one. It will validate. If you get an error validating, something is broken, you should stop. Do not just blindly click OK and then 6 hours later be like, oh, I don't know what I did. I have no clue. Every single time something breaks, there will be clues. Do not just randomly click OK on things that you did not read. That is a quick way to be singled out and fired. Just read the stuff. Read everything. I don't like reading. I'm sorry. IT is way more about reading than some people think. Read the error messages. It will save your life. Now, router, does that change? Heck no. pfSense is still a router. You can build a router in Windows Server, though. You can do that. Yeah, using a really expensive server to do that is probably not the best idea. So either way, DNS server, that's what needs to be there. Now, DNS domain name scope option. Here's what we want to do here. So configure options, DNS domain name. I forget what it is. I have a feeling it's in the 50s. Oh, no. I missed it. It's somewhere in here. There it is. 15, not 50. See, it was in my mind, just in the wrong way. win.lchavez.io. Here's the deal. I'm going to show you where this shows up. Because right now, using the old lease, we're going to have to get a new lease here in just a minute. You're going to see connection-specific DNS suffix. It's blank, right? It is blank. Windows uses this. Well, all operating systems use this. They just call it different things. As a way to fudge your names. So if I gave you a name Leo, and then you had the connection-specific suffix, just like this, of win.lchavez.io, it would try to resolve Leo. Does that work? Yes, no, maybe so. If it doesn't work, it will then try Leo plus the connection-specific suffix. So it would try leo.win.lchavez.io. So this is the whole reason we're setting this up, so that we can easily manage our DNS names without having to use the fully qualified domain name, right? Long story short, I don't want to have to type that a million times. So how about I just don't? Cool. Turn this on. Tell it what your actual domain name is. Cool. Now, make sure you take a screenshot of that. Okay. So in pfSense, what you're going to want to do is log into it first off. Consider why I still have internet, right? I changed all this DHCP stuff. Think about that. If you can't come up with an answer on that, let me know. We'll have a conversation about it. Oops. All right. So you want to go to general. So I've already got a name. I'm going to leave it my router just for funsies. And right now the domain is local domain. Well, I don't want that. win.lchavez.io. This is going to get a little fishy once we get into the Linux side, because that's going to be lin.lchavez.io, but we'll just come in and change win to lin so you can see how this works on the next lab. So for right now, that's it. Pretty sure. Oops. Change the domain name. Yep. Come down and save all that. And then if you go back to home, click on the logo here, you'll see the host name plus the domain name. So that is the first time we have taken a look directly at a fully qualified domain name. So remember, as you move left, it gets more specific. IO, top level, El Chavez, mine, win is a subdomain of my domain, and this is a device on that subdomain on my domain under IO. Cool. So now that we got that all situated, we can start putting finishing touches. Let's go create some records. So what we want to do is we want to have an A record and a PTR record to reflect both the pfSense server, or the pfSense router, and server 2016. I'm not grading you on this, but I really encourage you to add the A and PTR record for your Windows 10 machine. So let's add some records. All right, so out of DHCP snap-in, don't need that anymore. It's back to DNS. Whoa. Come on now. There we go. In there. Let's start creating some records. So all I've done is DNS in your server, forward lookup zone, in your forward lookup zone. Create a new record. And it only asks you two questions. Number one, what is the name of your machine? Let's name it. What are we naming it? What was it? SVR-01. Oh, no. Dash. Yeah, that's how it is down there. And what is its IP address? 172.16.100.2. Add host. Take a look. There it is. Right? Am I positive about that? Actually, no. But it doesn't matter because you can edit these records pretty quickly and easily. But 172.16.100.2, perfect. 172.16.100.2, awesome. SVR01, let's double check that. SVR-01, good. Everything is the same. So now, our DNS server will answer this question. You can do NS lookup space SVR-01. And you know what NS lookup will tell you? 172.16.100.2. And this tiny little text file is the whole reason that NS lookup will come back with an answer. The moment you delete it, NS lookup will no longer be able to give you an answer because this DNS server is the only guy in the whole entire world with the answer to this question. What is svr-01.win.lchavez.io? What is that? And that is the answer. Nobody else on the entire internet knows the answer to this question. Just your DNS server. That's why it's so important. And again, typing SVR-01 is way easier than typing out and remembering 172.16.100.2. So that's the whole reason you want this. All right, so let's do another one. My router, because I was so unique on that. 16.100.1. Now here's a trick. Check that box. So now we got my router. Perfect. With the right IP address. Awesome. Now let's go into the reverse lookup zone and create those same ones. Ta-da! The one that I checked the box on automatically created a PTR record for me. So here's the difference. A records literally means IPv4 forward lookup record. A. You just have to remember that. PTR is a pointer record. It is a reverse lookup zone record. Right? So A goes named number, or answers the question, I have a name, give me a number. And then the reverse lookup says, I have a number, give me a name. Forward and reverse. So since I didn't check the box on the previous one, we want to create a new pointer record. And the IP address of that guy is going to be .2. And the host name of that guy is SVR-01. And you want to do the fully qualified domain name here. win.lchavez.io. Right? And then it looks just like the one above it, except for the host name itself. Oops, forgot my dot. There we go. But if you are in doubt, or if for some reason it's not working, delete this record. Come back over here and delete this record. Just create it again and let it generate the PTR record for you. There's nothing wrong with backing up a little bit and doing stuff over again. Oh, it might be because of this, the parent folder thing. So, of course. I think I did it. If I did it the first time, it probably would have done it. Oh. Uh-oh. Oh, you know what? Ha! I'm silly. I just needed to refresh it. That's why. It was there, but it was invisible. So if that happens to you, if you create the PTR record or whatever and it doesn't show up, just use this button, refresh. Seems silly that it wouldn't do that on its own, but it is what it is. So anyway, you got forward lookup records, reverse records. I'm going to do one last one. This is, again, not for a grade, but I really recommend that you do it. So this is the name of my Windows 10 VM. The reason you typically don't want to do workstations is because their IP address can change sometimes. But Windows is pretty good about remembering who had what IP address, and as long as you don't run out of IP addresses, the people will still get the same IP address every time. So this is pretty safe to do on small networks. Otherwise, you can do static leases, where you instruct the DNS server to always give the same IP address to a specific MAC address, right? So it will check this and say, oh, you had 100 before, have 100 again. But it will force it every single time. Oh, did I not check the box? Dang. Oh, wait, refresh. Ah, see? Got me again. There it is. So all of my devices have DNS records. Now let's go test what's happening. Did we do this right? So at this point, you're just going to be using those things or checking these particular things and then submitting those to me. So we're about done with the instructions. But let me show you how to do each of these. First things first, if you're on your Windows 10 machine, you need to release your IP address. So the way you do that, if you remember, release that, and then renew that, and you should get the new information that you were getting that you had configured, right? So if you look, DNS servers was .1, connection suffix was nothing. Let's look at it again. That was the previous information. This is the new lease. We got a suffix now, and our DNS server is 2. Those are the changes that we made in the scope options. So if you skipped that, yep, go back and do it. You can't skip any of the things that I've got listed. Stuff will break. Anyway, so we should be to the point where we can start asking our DNS server, questions, and it should be giving us some answers. So we can start looking stuff up like this. So let's see what happens. So NS lookup. It tells you, oh, look at that, it already works. Do you know how it got this name? A reverse lookup. So when you do NS lookup, all your machine has to run off of is an IP address. It does not know its name. But because we have the reverse lookup record, the PTR record set up, it can resolve that and tell you, hey, this is the name of that server, and here's its address. So now we can start asking it questions. SVR-01. What's the answer to that? There it is. The server that answered it is this. The answer to the question just happens to also be the same thing. What about my router? The server that answered it, the machine, and its IP. And then, same thing. Server, device, IP. So what happens if we go the other way? Just because you look up something and you get the A record for it, the forward lookup for it, does not mean that you get the reverse as well. So you've got to populate that yourself. 72.16.100.100. And there you go. Same junk. All of these should resolve. If any one of these doesn't resolve, say you got 2 of them working but the other one doesn't, typo. Almost guarantee you it's a typo. Because if your DNS server is working, but yet one record is not, then the problem is with the record and not the DNS server. But again, double check when you do an IP config that your DNS server, wherever it is, DNS server is the correct server. If it's still .1, then pfSense is doing your stuff for you. Oh, which also reminds me, we got to go turn off DNS server or resolver. Just turn it off. We don't need it anymore. We're no longer using it anyway. Ta-da! Okay, that's how you turn it off. Easy peasy. Just as same as we did with the DHCP server. And that's it. So what I did was, oh, I see. I got to do the fully qualified domain name as well. So the only thing with that is same thing, just you can do 10.win.lchavis.io. And it'll give you the same thing. So this is host name. This is fully qualified domain name. Fully qualified is just the whole thing. Host name is just the name of the host itself. Notice, fully qualified host name. And then you want to look up the IP address here. And that should give you pretty much the same response. So do all these back to back to back to back. Take a screenshot of all of them. It's just easier to do it that way. Then you might be asking, why the heck do I want to do any of this? Well, check this out. myrouter.win.lchavis.io. Looky there. Or you could just type in. Different browsers are different, so you have to be careful with this. I think going with a slash works in Edge. Yeah. So if you just type in my router by itself, it'll try and search it on the internet, which is annoying. But if you stick a slash at the end of it, it will assume it is a web address. So it will try to go that way. Ta-da! So now you don't have to remember the IP address of your router. You can just remember whatever you named your router. If you are in the situation where your router resolves, but nothing else resolves, it could be that every other record is broken, but pfSense will resolve its own name every single time. So, long story short, double check that pfSense is not your DNS resolver anymore. We didn't create those records in pfSense, so it will have no idea about your Windows machine or your Windows server. All right, that's it. So I want you to do fully qualified domain name. By the way, just to clarify, I do not want you actually typing in pfSense FQDN unless the A record and the pointer record that you created is literally pfSense FQDN. And I know that it's not. So just don't type this in. This is an example. You need to type in https:// the fully qualified domain name of your pfSense machine. And then same here, https:// the host name of your pfSense VM machine. Right? Both of these options, do not type that in exact. Whatever it is for you, type it in instead. But that'll do it. As the whole setup, that's the whole network, that's the whole naming thingamajig. That's all of it. So if you have questions, obviously, come ask. Here in WebEx today for a little bit longer and on Friday, if you feel like you want to come in and ask some questions. Otherwise, of course, email, Slack, Hangouts, all that fun stuff.